going to talk about domain, range, and whether a graph represents a function. When we do domain and range in this video, we're going to be working with what's called interval notation. Interval notation uses parentheses and brackets, or a mixture of both, depending on the situation, to show the interval in which our domain range exists. So as we go through this, we're going to discuss when to use a parenthesis and when to use a bracket. The first thing we want to do for number one is we want to look at this graph and determine if it represents a function. If we think back to the vertical line test, anywhere I draw a vertical line, I will only touch the graph once, so therefore this does represent a function, and so therefore it is a function because it passes the vertical line test. So we're going to write down, yes, it's a function. For the domain, what we do is we look at our graph going from left to right. So for domain, we do left to right. As I start on the left, the very first time I hit my graph, I hit an arrow. So that arrow means that my graph is going to continue to the left forever. So forever to the left is negative infinity. Now, I continue moving over, and so I'm going to slide my line moving to the right until I get to this open circle right here. The x-coordinate of that open circle is 1. So that means that everywhere between negative infinity and 1, my graph exists. Because it's an open circle, open circles get parentheses. So we have just identified the two things that get parentheses. Parentheses are always for infinity. So negative infinity or infinity, they always get parentheses. And then also open circles. So open circles also get parentheses because that means we get really, really close to the point of 1, but we don't actually equal it. Now for the range, we do the same thing, only now we go from the bottom to the top. As I start at the bottom and work my way up, the very first thing I hit is an arrow. So that arrow is going to go down, which means it's going to go down forever, and forever down is negative infinity. Now, as I continue up, the highest my line goes is this open circle, and the y-coordinate of that open circle is 2. So my range goes from negative infinity to 2, and once again, we use parentheses here because we have an open circle. For number 2, if we try the vertical line test, when I get over here, oops, now I hit twice. So that means that I fail the vertical line test, so this is not a function. Looking for the domain, I start moving from left to right, and the very first time I hit a point is right here when my x-coordinate is 2. So my domain starts at 2, and this time it gets a bracket because that's a filled-in circle. So closed circles get brackets. Now, as I continue to the right, when I hit the furthest point of my graph, I have arrows, which means that my graph is going to continue forever to the right, and forever to the right is infinity. If it helps, we can label our graph. So going up is infinity, going down is negative infinity, going to the right is infinity, going to the left is negative infinity. So if you have arrows pointing in those directions, those are the numbers you're going to use to close your interval. Now, for the range, when I start on the bottom and moving my way up, the very first thing I hit is an arrow. So that means that this graph is going to continue to go down, down, down. So down is negative infinity. Then I'm going up, 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 and then I hit this arrow and I'm going to keep going up, up, up. So if I'm going to go up forever, I'm going to stop when I hit infinity, which there isn't even really a place to stop. It's a concept. So we're going to go from negative infinity to infinity because we have arrows on both sides. For number 3, if we look at our vertical line test, yep, we're all good. A vertical line touches the graph only once, no matter where we put it. So yes, this is a function. For the domain, I'm going to go from left to right. So as I go from left to right, the first thing I hit is an arrow. So that means that I'm going to go to the left forever. Now remember, forever left is negative infinity. So my domain starts at negative infinity. And then as I continue to the right, the last thing I hit is also an arrow. So that means I'm going to keep going forever right, and forever to the right is infinity. For the range, remember we go bottom to top. So at the bottom is negative infinity, at the top is infinity. So bottom to top, as I head up, the first thing I hit is an arrow. So that arrow means it's going to go down forever. Down forever is negative infinity. Then I keep going up, 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 and I stop right here when my y coordinate is 2. If I erase what I just drew, I can see there isn't specifically a point there, but because we have this curve with all these connected points that make a line, so it's not a line because it's not a linear function, but it's a line that we would draw with our pencil, so we call it a curve. Okay, so this curve is connected everywhere, which really what that means is we have an infinite number of points that are so close together that they have formed a solid curve. So the highest pace of that solid curve is 2. And even though we don't see like a specific point drawn there, the point exists because the curve exists. So we put a bracket. If we take a look at number 4 is a function. It passes the vertical line test. For the domain, I start on the left, and the first point I hit is right here at 1, 2, 3, 4, 5, so that's negative 5. So my domain starts with a bracket at negative 5 because that's a filled-in circle. We use a bracket. And then as I continue to the right, there's an arrow, which means I'm going to go forever right, and forever right is infinity. For the range, we go bottom to top. So from the bottom, the first place I hit a point is right here, and the y coordinate of that point is 0. And then as I follow my curve, I've got an arrow, so that means it's going to keep slowly getting bigger forever, even slower than that actually, but it slowly gets bigger forever. So we have an infinity. Number 5, we have points. So yes, this is a function. Because we have points, we can't use interval notation because it's not everything in between. It's only those specific points. So we go back to set notation. So the domain is all of the x values. So from smallest to biggest, 1, 2, 3, 4, 5. This one has an x coordinate of negative 5. This one's at negative 2. 1, 2, 3. This one's at 3. 1, 2, 3, 4, 5, 6, 7, 8. This one is at 8. So I've written down my x values from smallest to biggest. For the range, we write down the y values from smallest to biggest. So the smallest y value is for this point over here, 1, 2, 3, 4, 5, 6. So it has a y coordinate of negative 6. Next are these two, which are tied at 2. Remember, if it's a duplicate, we only write it down once. And then our last point is up here at 1, 2, 3, 4, 5, 6. So when we have points, we list out the specific x coordinates for the range, for the domain. Sorry, x is the domain. And then we list out the y's for the range. And we always list them from smallest to biggest. And we always put them inside these squiggly braces because these squiggly braces represent set notation. So this is the proper mathematical way to write these. Okay, we're going to skip ahead. I want to look at number 7. Number 7's interesting because we have lots of little pieces. So when we have lots of little pieces to put together, we use a union symbol. So the first thing we have to check is, does this represent a function? Well, we've never seen anything that looks like this before. If I draw a vertical line, it goes through a filled-in circle and an open circle. This is okay. The open circle, remember, means that that point is not included, but we get really, really close to it. So if you have an open and a closed on top of each other, it's still a function because the open circle isn't actually a point. Okay, remember it says we're getting really close there, but not actually touching it. So is it a function? Yes, it's a function. Now, for the domain, we start from left to right. So on the left, we have an arrow. So remember, an arrow on the left means negative infinity. Now, I keep going and I hit that open circle, and then I'm going to jump up here to the closed circle. So in terms of the x's, we didn't actually miss any x's because the x right here at 1, 2, negative 2, so it would be an open circle, so we would miss it, but this one up here fills it in, so we're good. We still have a value at negative 2. And then I keep sliding and I hit this one, so that's filled in. I jump up, I have the open one, and I keep on going. So from left to right, everything everywhere is represented because these open and closed circles are stacked on top of each other, so there's no gaps. Now, the range is a little bit trickier. Okay, so the range, I go up and then I hit this line right here. And that line is at 1, 2, 3. Now, I only have 3 here. Like it's not going up anywhere. And then I have this gap until I get to 4, 5, 6. So then I have a gap until I get up here to 6. So to represent that gap, I'm going to say, okay, I have points at 3. Then I have a gap. So the gap is represented by a U. It's a mathematical symbol. It's not actually the letter U. So don't put a tail on it. It's just a U. Then I jump up to 6 and I have all these points at 6. And then I jump up again, 7, 8, and I have all of these points at 8. Now you're thinking to yourself, Miss Brown, you messed up because those are open circles, so you shouldn't include them because open circles get parentheses. Well, that's where it's a little bit tricky because even though there's an open circle right here, all of this line means that everywhere here, 3 is filled in. So even though there's an open circle at the end, that's not going to mess up the brackets on the range because we have all of these points right here that make up the line at 3. And then the same thing, we have all of these, and we have the filled in points at 6. And then at 8, we have all of these ones over here that are up at 8. So even though the beginning point isn't included, everything else fills in at 8. Here's another sneaky one in number 8. So it's a vertical line. So is it a function? No, because a vertical line fails the vertical line test. For the domain, I only have one number, right? Because I just go straight up and down right here, so there's only one x value. So we just put negative 2 in a bracket and we're done. Okay, because the only x value represented is negative 2. And then the range, we have an arrow going down and an arrow going up, so the range is negative infinity to infinity. And the last one we're going to do is number 9. So for number 9, is it a function? Yes, it passes the vertical line test. For the domain, I'm going to go from the left to the right. So on the left, I start, my first point I hit is this one right here. So if we count, that's at 1, 2, 3, 4, 5, 6, 7. So I start when x is negative 7. And I put a bracket because if I erase what I drew, we can see that that is indeed filled in. Now I follow all the way over to the right, and the furthest right I go is this point right here. So if we count, that's 1, 2, 3, 4, 5. So I go from negative 7 to 5. For the range, same thing. We're going to go from the bottom to the top. So the bottom happens right here. So if we count 1, 2, 3, 4, that's at -4. The top happens right there, right? From the bottom to the top. So the top of the graph is right there. And if we count, that's 1, 2, 3, 4. So the range goes from -4 to 4. And I feel bad we skipped number 6. Let's go back and do number 6, and then we've done them all. So, is this a function? Yes. It passes the vertical line test. The domain, well, there's arrows pointing to the left and to the right, so this means that this is going to be from -infinity to infinity. And then the range is the bottom, so the bottom is right here, 1, 2, 3. So, oh, not a -3, Miss Brown, just a regular 3. And then when I get to the top, I have arrows, so it's going to go up to infinity. So, a quick little recap. Arrows either represent infinity or -infinity. If the arrow is going up or to the right, that's positive infinity. If the arrow is going down or to the left, that's negative infinity. If our point is filled in, we use a bracket. If our point is an open circle, we use a parenthesis. If we have just regular points, like in number 5, then we have to list out all of the x values for the domain going from smallest to biggest, and then all of the y values from smallest to biggest for the range. Like we saw in number 7, a graph can still be a function if there's an open circle on top of a closed circle or a closed on top of an open. So that's okay because an open circle is not included. So it's okay to have them stacked on top of each other. It's still a function. If our number doesn't change, so we saw that for 7 and 8 where we had values that didn't change, like the range was just 3 for that piece. We just put that one number. And then we did the U to show that there was a gap. And then we tied that together with the 6. And then there was another gap. And then we put that together with an 8.